couple of equations. First of all, we have this equation, Cu divided by Q times max, or max. So this is one term, and this one term is equal to e to the a plus b times natural log h plus c times natural log h squared plus d times natural log h cubed. What are we doing with this? Well, we're calculating this so that we can put it into this equation, our Cmax, which is our maximum downwind ground level concentration, is equal to Q divided by U times this Cu over Q max term. So don't get confused thinking this is separate terms, Cu and Q. This is a single term here that you get from this equation up here. Okay, so we're going to look at table 20.4 first of all. So notice we have A, B, C, and D. This is different. This is our different A, B, C, and D than the ones that we used previously in the others in part B. So these are different. So these are for calculating the stability in the ABCDF, whereas this is for calculating our CUQ max. And so here we're going to look, we've got a stability of D, and so that means that our A is equal to negative 2.5302, our B is equal to negative 1.5610, our C is equal to negative 0.0934, and our D is equal to 0. So that's these values right here, and I've just copied them over. Okay, so now we have those. We can go ahead and calculate our term, our CUQ max term. And so that is equal to negative 2 e to the negative 2.5302 plus negative 1.5610 times natural log, and remember this is big H, so our big H is in this case 187 meters, plus our negative 0.0934 times natural log of 187 squared, and then because D is 0, we have plus 0 at the end. Close that up, and we can go ahead and do the math. Cu over Q max is equal to 1.757 times 10 to the negative 6th, and that's meters to the negative 2. And then now that we have this, we can go ahead and put it into this equation right here. And so our Cmax now is equal to our Q, which is 1.5 times 10 to the 8th micrograms per second, so that's our mass flow rate, divided by our U, and this is at stack height, so 4.37 meters per second, times our CUQ max term, which is 1.757 times 10 to the negative 6. Shh. And sorry, that was my dogs. And just ignore them. And then we have our Cmax, we calculate as 60.3 micrograms per cubic meter, and there is our answer. Now, I kind of gave you a little bit of a freebie with this extra credit. I asked you what y distance from the center line does the maximum concentration calculated above occur. Well, if we recall what it looks like when we have plume release like this, pretty much right along that center line, you're going to have that maximum concentration because it's going to disperse outwards from that maximum. And so because of that, that means that if this is our x direction here, and then this is our y direction here, and z direction of course going up, then in our y direction, it should be y equals 0 to get our maximum. So that's the answer there, and hope that all makes sense to you. now.